Welcome to Paradox Lab. When looking up at the night sky, we imagine the stars lying close to one another. But that is merely an illusion of perspective. The human eye only sees the incoming light and cannot inherently perceive the colossal depth hidden behind it. Therefore, objects that are millions of light years apart can still look as though they are standing right next to each other in the sky. Our brains are accustomed to distances on Earth, so when looking at the universe, they almost completely lose their ability to judge. A tiny point of light could be a nearby star or an entire massive galaxy located very far away. The terrifying thing is that from the ground, two completely different things can still appear absolutely identical. The night sky is like a flat painting, where all true distances are compressed into a single dark surface. But behind that painting lies a three-dimensional space, so vast that human intuition is practically useless. Like looking at a forest from afar, you see the trees close together, but the true distance has completely vanished. The universe is the same, except that distances are no longer measured in meters, but in light years. And when the unit of measurement is already a light year, all familiar senses of near and far begin to collapse. What you thought was just a small gap might actually be a dark void spanning millions of light years. That is why galaxies appear as if they lie in the same layer. Even though they are actually at different depths, we do not see their true positions. We only see ancient light arriving from all directions. That light gives us an image, but it does not tell us how long it has traveled to reach our eyes. Thus, the more beautiful the sky, the greater the deception. For that seemingly intimate closeness conceals unimaginable distances. Even galaxies that appear to be lying next to each other in a photograph might actually have no relation to one another. They simply happen to lie in the same line of sight from Earth, like two streetlights on two very distant roads. Before asking if humans can fly to another galaxy, we must understand that they were never close to begin with, because right from the very first glance, the universe has made us misjudge its true vastness. In the previous part, we learned that the sky deceives the human eye. Now let's measure the true distances between galaxies to see their terrifying remoteness. The large galaxy closest to us is Andromeda, and the word close here alone carries a completely different meaning. Andromeda is about 5 million light-years away from the Milky Way, a number that sounds simple but almost exceeds the bounds of imagination. In other words, the light left Andromeda before the ancestors of humanity even appeared, and only today has it finally touched our eyes. If you were to convert that distance into kilometers, the number would be so immensely long that looking at it would leave you feeling almost nothing. A single light year is already equal to nearly 9.5 trillion kilometers, so 2.5 million light years is an abyss, and Andromeda is still just the closest large galaxy. This means that the most pleasant example is already enough to drive humanity to near despair. Within our local group, large galaxies like the Milky Way, Andromeda, and Triangulum are still separated by voids spanning millions of light years. This means that even in our own cosmic neighborhood, our neighbors are not close to each other at all. If you were to shrink the Milky Way down to the size of a plate, the Andromeda galaxy would still have to be placed an incredibly far distance away. Many people think that between two galaxies, there would be a dense region of stars, dust, and gas. But in reality, the vast majority is just a cold, empty void. That emptiness is not just a few long stretches of road, but a black ocean spanning millions of light years. Even for closer dwarf galaxies, their distances are still enough to make a journey by modern spacecraft absolutely absurd. The problem lies in the fact that a number in the millions of light years is so huge that our brains hear it, but cannot truly comprehend it. Imagine traveling around the Earth countless times and multiplying it again. You still wouldn't reach the scale between two galaxies. Therefore, when hearing that there are roughly 2 trillion galaxies, the terrifying aspect is not just the quantity, but also the distance. The observable universe is not a crowded city, but rather like a vast dark continent with brightly lit islands isolated far apart. Each galaxy is a colossal world of stars, but between those worlds, it is mostly silence, coldness, and emptiness. So before you discuss flying across galaxies, we must accept the truth that our cosmic neighbors are terrifyingly far away. And that is just the first step in understanding the magnitude of distance, before we realize that light makes things even more daunting. You might think that light is the fastest thing in the universe, so traveling between galaxies wouldn't take too long. But the truth is that even light takes millions of years to cross the distance between two galaxies. This means that when you see a galaxy, you are seeing it in the very distant past. The light you see today may have left that galaxy before humans even existed on Earth. In other words, you never see the universe as it currently exists, but only what has already happened. Even the sun you see is an image from 8 minutes ago, not the present moment. But when the distance increases to millions of light years, that delay is no longer measured in minutes, but in millions of years. This makes observing the universe akin to watching a slow-motion film that spans millions of years. Every galaxy you see is an outdated version of itself, delivered to you through light. And the terrifying thing is that its current version might have completely changed without you ever knowing. Light not only carries information, but also limits what you can know about the universe. You can only know what the light has managed to bring. Everything beyond that reach remains completely invisible. This creates a natural boundary for observation called the cosmic observable horizon. Outside that boundary, light hasn't reached us yet, so we are absolutely unable to see anything at all. Therefore, the universe could truly be vastly larger than what we are currently seeing. No matter how fast light is, it is still not fast enough to help us cross the distance between galaxies in a short amount of time. And if even light needs millions of years, then any slower modes of transportation become virtually meaningless. This establishes an almost unbreakable physical limit for any intergalactic journey. It is not because we lack sufficient technology, but because the very structure of the universe has made everything insurmountably remote. And that is when you begin to realize that the distance is not only vast, but also locked away by the laws of physics themselves. After understanding that even light takes millions of years, the next question is, with current technology, how long would it take humans? The fastest spacecraft humanity has ever built is Voyager 1, and it is still flying out of the solar system. Its speed is about 17 kilometers per second, which sounds very fast, but in the universe, that number is practically negligible. If you used this speed to reach the Andromeda galaxy, you would need about 40 to 50 billion years. That number is many times greater than the current age of the universe, making this journey virtually meaningless. Even if you started the journey today, the universe might have changed entirely before you arrive. This is no longer a problem of poor technology, but rather an astronomically vast distance compared to current travel capabilities. In the space between galaxies, you have no stopping points, no supplementary fuel, only an endless void. All systems on the ship must operate stably for millions of years, something we are currently completely incapable of achieving. Even keeping humans alive through such a long journey is an almost unsolvable challenge. One solution once considered is the generation ship, where many generations are born and die throughout the journey. But even that idea encounters countless issues regarding resources, psychology, and stability over an extremely long period. Meanwhile, the ship itself must endure the harsh environment of space for millions of years. Just one small error accumulating over a long time could end the entire journey in disaster before reaching the destination. This makes intergalactic travel with current technology not just difficult, but practically impossible to execute. And that is before we even consider that galaxies are not standing still. They are continuously moving further away. Meaning throughout the journey, your target is also gradually drifting farther off, causing the distance to constantly increase. You not only have to overcome the initial distance, but must also chase a fleeing target. All of these things show that with current technology, a journey between galaxies remains utterly out of humanity's reach. And this is merely the first step, because even if you go faster, you still have to face deeper physical limitations. You might think that simply accelerating fast enough would allow humans to shorten intergalactic journeys to an acceptable level. Imagine a ship reaching 10% of the speed of light, faster than anything humans have ever created. It sounds impressive, but to reach Andromeda, you would still need about 25 million years to complete the journey. That number is so large that the entire civilization of humanity could rise and fall multiple times before the ship arrives. Even if you push the speed to 50% of the speed of light, the journey would still last millions of years. This means that being faster is not enough, because the distance is vastly greater than any improvement in speed. You can increase your speed by 10 or 100 times, but the distance will still far exceed all your efforts. This is no longer an engineering problem. It is a problem of scale where humans are facing the true size of the universe. Even if the ship operates flawlessly, the next issue is that humans cannot live long enough to finish the trip. This leads to the concept of generation ships, where your descendants will continue the journey that you will never see the end of. But when time stretches for millions of years, even the concept of a generation becomes too small. You are not only passing down a journey, but also a goal that is almost impossible to achieve. Meanwhile, the ship itself must also survive and operate stably over periods of time that far exceed human history. Any minor flaw can accumulate and become a catastrophe given enough time. And when you think you have solved the speed issue, you realize that time is an even greater barrier. In the universe, high speed does not guarantee you arrive quickly, because the distance is always greater than any expectation. This is when humans begin to understand that the issue is not about going faster, but that the distance is too massive to overcome. Even the most optimistic scenarios cannot make intergalactic travel feasible within a reasonable time frame. You might dream of near-light speeds, but the universe still maintains its distance at a level that renders all dreams out of reach. And that is when you realize that even at near the speed of light, a journey between galaxies remains nearly impossible. As speed approaches the speed of light, a strange thing happens. Time no longer flows the same for everyone. This is a consequence of the theory of relativity, where speed not only affects motion but also alters how time operates. For someone standing still on Earth, time passes normally, but for someone on a fast-moving ship, time slows down. Meaning when you travel very fast, you might experience less time compared to those who are left behind. This is called time dilation, and it is not a hypothesis. It has been verified by many real-world experiments. If a ship flew near the speed of light, the passengers might feel the journey lasted only a few years. But when they return, they will see thousands, even millions of years have passed on Earth. This creates a paradox of perception, where two people experience the same journey but live within two different timelines. With sufficient speed, you can jump into the future of the universe without feeling the entirety of that time. This makes intergalactic travel profoundly bizarre. You might arrive in your lifetime, but everything you knew would be gone. You leave a familiar world, but upon arrival, you have been severed from your original timeline. In a sense, you are not only traveling through space, but also traveling toward the future of the universe. However, even though your time slows down, the physical distance between galaxies remains completely unchanged. You might feel the journey is shorter, but in reality, the universe still requires you to traverse that colossal distance. This shows that the theory of relativity doesn't help you shorten the distance. It merely changes how you experience time. And even if you accept the trade-off of your personal time, you still have to face the speed of light limit. No object with mass can exceed the speed of light, making this limit almost absolute. That means that while you can travel faster in perception, you cannot travel faster than physical reality. The theory of relativity opens up a new way of understanding time, but simultaneously reminds us that the universe has unbreakable boundaries. And when you combine speed, time, and distance, you begin to see the true picture of the remoteness between galaxies. At this point, you might think the distance is terrifying enough, but the truth is even more frightening. The universe is not standing still. Galaxies are not merely far apart. They are also continuously moving further away from each other over time. This phenomenon is called the expansion of the universe, and it is happening everywhere without exception. It is not that the galaxies are flying through space, but rather the space between them itself is being stretched out. This is like the dots on a balloon being inflated, where every point gradually moves further apart. The further away a galaxy is from you, the faster it recedes, creating a relationship between distance and speed. This means that distant galaxies are not only difficult to reach, but they are also increasing their distance from you every second. You are not merely traversing a fixed distance, but attempting to cross a continuously growing one. Even if you travel at high speed, the expansion can still make the journey longer over time, and in some cases, distant galaxies might be receding faster than the speed of light itself. This does not violate physics, because it is space itself that is expanding, not the object moving past the limit. Meaning there are places in the universe from which light will never reach us. And if light itself cannot reach us, then humans have even less of a chance to touch those regions. This is one of the most profound limits of the universe. Not everywhere is accessible. You might start a journey, but the target could vanish from reach before you even get close. This makes intergalactic travel not only difficult, but potentially completely impossible in many cases. The universe is not only vast, but it is also actively pulling structures apart from one another over time. With every passing second, the distance between galaxies increases a bit more, no matter what you do. This turns cosmic travel into a race where you are always trailing behind, never catching up. And that is when you realize it is not just because it's far, but because the universe is actively making everything further away. As the universe continues to expand, a chilling truth emerges. Not every galaxy remains within our reach. There are galaxies we still see today, but they have actually fallen out of the region that humans can ever touch. Their ancient light is still arriving, but newer light may never reach Earth. This creates an invisible boundary, beyond which information can no longer return to us. That boundary is not a physical wall, but a limit imposed by the speed of light and expansion. You cannot crash through it like breaking down a door, because it does not exist at a fixed location. It is like the horizon on the ocean. The further you advance, the further it retreats from your sight. But unlike the horizon on the ocean, the cosmic horizon can render a place forever inaccessible. If a galaxy crosses that boundary, all signals from its future will no longer reach us. We might still see images of its past, but its future has been locked away by the universe. This means that the night sky not only contains distant objects, but also holds places that are disappearing from our scope of knowledge. We are not only restricted by technology, but also restricted by the very causal structure of the universe. Wherever light cannot bring information back, that place is practically severed from reality for us. You could call it distance, but it is more accurately a permanent separation. And the most terrifying part is that this process does not stop over time. More galaxies will vanish out of reach. The universe of the future will be darker, emptier, and later civilizations might see fewer galaxies than we do. This makes the present moment deeply special, because we still see so much ancient light. But seeing does not mean touching. Many places are merely memories of light drifting toward us. This is the harshest limit. There are cosmic doors that do not shut before our eyes, but silently disappear. And when we understand that, we realize the universe is not only remote, but is also quietly leaving us. At this point, a massive question arises. Why is the universe expanding and pulling the galaxies so far apart? To answer, we must look deeper into the things we cannot directly see, yet which govern the entire universe. One of those is dark matter, a substance that does not emit light, but generates the gravitational force that keeps galaxies intact. Without dark matter, many galaxies might have disintegrated long ago due to their own rotational motion. But dark matter is only part of the story, because there is another, stronger force stretching the universe apart. That force is called dark energy, a mysterious form of energy that accounts for the majority of the universe's total energy. Unlike gravity, which pulls things together, dark energy causes the space between galaxies to expand. And what is remarkable is that dark energy does not weaken with distance. but continues to operate on an enormously vast scale. This makes the expansion not only persistent, but it can also accelerate over time. Therefore, galaxies are not merely moving away from each other, but the speed of their retreat is getting larger and larger as time goes on. However, not every place expands in the same way. Inside a galaxy, gravity still keeps everything stable. This creates the unique structure of the universe. Galactic islands situated within an expansive web. Between those islands are colossal voids that contain almost nothing, known as cosmic voids. It is exactly these empty spaces that make up most of the universe's volume, causing galaxies to become increasingly isolated. The universe is not a uniform mass, but rather a complex web with clear distances and structures. This explains why galaxies do not clump together into a single large mass, but are distributed sparsely throughout space. The combination of dark matter and dark energy has shaped how the universe evolved from its very earliest moments. What we see today is the result of billions of years of interaction between these invisible forces. And it is precisely this structure that makes the distance between galaxies not random, but an inevitable consequence. When understanding that, we realize the universe is not chaotic, but operates according to profound and cold laws. After everything, we confront a clear truth. Traveling between galaxies is practically impossible with our current understanding. But humans have never stopped simply because of a limit. We always find ways to understand instead of physically touching. Instead of traveling into the cosmos, we learn to let the universe tell its own story through light. Every ray of light you see is an ancient message containing information about where it was born. Telescopes do not help us travel further, but they help us look deeper into time and space. We don't need to touch a galaxy to comprehend it, because its light has already brought the entire story to us. This turns observation into a form of travel, where you travel through time instead of space. You don't fly to that place, but you can still witness its past as if standing right in front of it. This is how humans transcend boundaries, not with speed, but with intellect and the ability to decode. Every step forward in science helps us go further without ever leaving this planet. However, this also serves as a reminder that there are limits we can understand, but cannot cross. The universe is not merely a place to explore, but also a place to accept the profound limitations of reality. And it is those very limits that make understanding the universe all the more meaningful. For every discovery is a rarity. We may never set foot in distant galaxies, but we can still understand them more clearly every day. This makes humanity the only species capable of touching the universe through its intellect. Space might be vastly remote, but knowledge helps shorten the distance between us and the cosmos. And perhaps the inability to go there is exactly the reason why we endlessly yearn to understand it. The universe is not only a physical journey, but a journey of awareness that spans the entirety of human history. If one day you had the chance to go to another galaxy, but it would take 1 million years, would you be willing? Or would you choose to stay behind, observing and understanding the universe the way we continue to do today?